And then the last example is, and we didn't do it, what if we were, moving upward and we go to a stop? So we were moving decently fast and you're slowing down. What happens to acceleration there? Well, I'm moving upward, but I'm slowing down. So I'm moving positive, but I'm slowing down, which means your acceleration is actually negative. So in this particular case, everybody's moving and slowing down to a stop. But remember, your inertia, even though the elevator is slowing to a stop, your inertia, you want to keep on going upward. And yes, there's gravity pulling on you, but you want to keep on moving upward. Because your inertia, right? An object of motion wants to keep on moving. So the elevator is coming to a stop, but you want to keep moving upward. So you're going to feel lighter again. And so if your acceleration is downward, that means that this normal force has to be lower than your weight. So then we gotta, change that out again. Maybe now it's up to 400 again. So, or down to 400 again. So be aware of these things. Be aware of what's the direction of acceleration with regards to the motion, and how is that, scale going to read, or how are your feet going to feel against the floor with this motion? How's that floor pushing on you when the elevator is moving and accelerating? And remember, it's that normal force, which is what we call your apparent weight. What do you feel versus what you actually are in terms of gravitation? So I hope this made sense, and we're going to follow up with this. Thanks. I forgot to mention one more thing. I forgot to mention, what happens when you are moving at a constant speed, right? So if we were moving at a constant speed during any of these situations, and it doesn't matter if I'm moving at a constant speed, if I'm moving up or if I'm moving down, but if I'm moving at a constant speed, if V is constant, that's terrible. That is absolutely, let's redo this. So if V is constant, doesn't matter if it's up or down. Well, what's your acceleration when V is constant? Acceleration is 0. So when your speed is constant, yes, you can be in motion, but the bathroom scale, or what your feet feel, is going to be equilibrium. So when velocity is constant, that's because acceleration is 0. If acceleration is 0, this whole side goes to 0. Then what happens? Well, then I can solve this and say, well, then Fn equals the 500, right? Because that's the whole other side is 0. This is 0, actually. So be careful about, be careful about this. When acceleration goes to 0, this whole thing goes to 0. Forces are balanced. Got me? All right, thank you. I forgot to mention one more thing. This is a problem of apparent weight. We did a situation where a person's in an elevator, but this whole situation and concept we've kind of done before. If you were to think about an object vertically hanging just on a string, and you had that object, and it has gravitation. And instead of a normal force, what if we had a force tension? Well, isn't this force tension similar to the normal force? Right? And what that's going to do is, depending on the amount of normal force, instead of the, come on, Tapper, talk. Depending on the tension, it's going to tell us, is this object stationary? Is it moving at a constant speed, whether it be up or down? That would be all the gravitation and the tensions are equal. Or is this accelerating upward or downward? Or is it slowing down as it falls down? Or is it slowing down as it goes upward? Or is it basically, instead of analyzing the normal force and gravity, you're going to be analyzing the tension and the gravity. So it's the same arguments as above. So just be careful. It doesn't have to be a person in an elevator. I can ask you these same concepts with a mass on the end of a string or something of that nature. Instead of the weight of instead of your apparent weight, instead of you feeling lighter or heavier, the object may feel lighter or heavier depending upon how much tension is applied to the object. So keep that in mind. Okay. Well, trust me, we're going to practice this.